So today we are going to graph a piecewise function. We have looked at piecewise functions before in 1.1, I believe, and just a reminder that a piecewise function is defined by two or more equations over a specified domain. Okay, so today we've evaluated piecewise functions at different points, but we haven't actually graphed one. So I wanted to do a couple of examples of graphing a piecewise function. And so essentially what we're going to do, so this is f, and it is defined by two different equations for different pieces of the domain. And so what we need to do to graph it is to graph each equation over it just in this specific domain. So it's kind of like I'm going to break my graph up into pieces, right? Piecewise function. And then I'm going to graph each one in each part. And the important part here is to not have my graphs be overlapping and to only have the graph of each of these equations just in its specified domain. So what I kind of like to do here, just to sort of help me along, now this isn't actually part of my graph, but it helps me to sort of break the graph into pieces, is that the change over here is at x equals 2. So I'm going to draw this sort of invisible line here at x equals 2. This is a line that basically I'm going to have one graph on this side and I'm going to have one graph on this side. It's very light because it's actually not part of the graph, but it'll help me visualize where my graph is supposed to go. Alright, so 2x minus 4 is the graph that is defined for x greater than 2. So let's choose a few points here. So I'm just going to put my y up here so I know which one I'm using here. So I only want to choose values greater than 2. Now, actually, this particular part is not actually defined at 2, but I still need to know where it attaches. So I'm going to figure out where does it attach at 2. So if I plug in 2 for my x, then I'm going to get 4 minus 4, which is 0. So I'm going to put that point on my graph at 2, 0. Now again, it's not defined here, so I'm going to leave an open circle here. That's where it's going to attach to that line at x equals 2. Alright, so then I'm going to choose maybe just another point here. If I plug in, I don't want to plug in another 2. How about if I plug in 4 this time, something bigger than 2? Then I'm going to get 2 times 4, which is 8, minus 4, so this gives me positive 4. So I come over here to 4, and I'm going to come up here to 4. I'm not going to graph a lot of points here because this is actually a line. We're going to learn that later on, that this is a linear function, and so my 2 points will give me enough. So my graph goes on and on and on in that direction. Now if I wasn't sure what this piece looked like, I'd graph a few more points over here, bigger than 2. Alright, so that's that piece of the graph. So now I'm going to look at the other piece, which I'll make a table for. Again, this time I have negative x minus 3. Now again, I definitely want to know where it is, what my value is at 2, and since this one is defined at 2, that will actually be a filled in circle. So if I plug in 2 here, now I have negative 2 minus 3, which gives me negative 5. So my point is, I need 1, 2, 3, 4, 5 down here on this line, and it's filled in. Now my graph is only going to go in this direction, right? It's only going to be in this part. So let me pick another value. How about if I plug in 0? If I plug in 0, then my value here is negative 3, and so I have this point here. And let me just plot one more point on the other side. Maybe negative 2 will work. If I plug in negative 2, then that gives me minus negative 2 minus 3. So this actually becomes positive 2 minus 3, which is negative 1. So I have this point here as my third point. Again, it looks like a line, so I'm going to, and this one gets an arrow going in this direction. Okay, so it is still a function. It still does pass the vertical line test. The only question will be right here, and so make sure that you have one open circle and one filled in dot, or else you're going to fail the vertical line test. And since this has a name f, that means it is a function. Right. So let me do one that has 3 pieces to it. Okay, so this one's defined in 3 different pieces. So this time I'm going to draw two sort of like little boundary lines. So I have a change over here at -2. So this is sort of my invisible line, not actually part of my graph, but a good boundary for me to use. And then the other changeover is at x equals 0. Well, if x equals 0, that's actually the y-axis. So really the y-axis is also a boundary. So I have three different pieces. So over here, my graph will look like y equals minus, or actually 4 minus x squared, because that's the part that's defined for less than -2. In between here, this little piece here, I have 3 plus x. It'll look like that in between here. And then out here, greater than 0, my graph will look like y equals x squared plus 1. Okay, so I guess we'll just work from left to right. All right, so let me make a table here. Now in the next section, we're going to know better what these graphs look like so we don't have to graph so many points. So I'm just going to graph a few points and then use my knowledge to fill them in, but if you don't know what these look like, then you should graph a few more points than what I'm going to do here. So again, I always need to know at the boundary where is -2 defined. So here I'm going to have, let me use 4 minus x squared here, so I'm making sure I'm using the appropriate, I'm graphing this part. So -2 is the biggest value I'm going to use because everything else is less than -2. So if I plug in -2, then I have 4 minus -2 quantity squared, which is 4 minus 4, which is 0. Okay, so this is going to attach at -2, 0, and it's going to be open, again, because there's no equal sign here at -2. Now this is a quadratic, and quadratics always have sort of a U shape to them. So this is actually a negative x squared, so it should be like a downward type of U shape to it. So let me choose another point that's smaller than -2. If I have, let's say, -4, then I'm going to have 4 minus -4 squared. So I have 4 minus 16, which is actually -12. Okay, so I'm going to have a point way down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll say it's somewhere down here. All right, so I'm going to give this a little bit of a curve to it. If I wasn't sure that this was curved, then I'd want to add a couple more points to it. But I do know that this is a curved graph. And if I'm going to plug in bigger and bigger negative values, I'm going to get bigger and bigger negative values here. You can kind of tell if I plugged in x equals -9, then I'd have 4 minus 81, which would be even more negative. So my graph is going to keep falling and falling and falling. All right, so now let's move into the middle part. So this time I have x, and I'm going to use the 3 plus x. So for sure, because this one, the boundaries are at -2 and 0, I want to plug in -2 and 0. So 3 plus x should be a straight line because there's no exponent on x. I have 3 plus -2, which is going to give me +1. Okay, so that means I'm going to have a point here, and it's actually defined at -2 here. So when I put this point on here, it should be filled in. And then when I plug in 0 here, I get 3 plus 0, which is 3. Now 0 isn't defined here, so when I put this point on my graph, I'm not going to fill that in. It's going to look like this. So that piece just looks like this. Okay. All right, so then I have my last piece of my graph. And I'll make a table over here. Again, I'm going to pick, this is for x greater than 0, so I need 0 and maybe just a couple more points. We'll choose 2 and we'll see what happens. So when I plug in 0 here, I get 0 plus 1, which is 1. And this is defined at 0. So at the point 0, 1, I'm going to have a filled in point here where this graph is. I plug in 2, and I get x squared plus 1, so that's 2 squared plus 1, which is 5. So at 2, I'm going to have 4, 5 up here. Now this might look like a straight line, but it is in fact a curve. If I put in, let me just put in a number in between 0 and 2. So 1 then I'm going to get 1 squared plus 1, which is 2. So I have the point 1, 2. So you can kind of see these aren't really in a straight line, that's more in a curve. And this curve behaves like this. Okay? So I have my 3 distinct pieces, right? It's just, it's 3 different graphs just sort of put together on the same coordinate system. So this is how we graph piecewise functions. If you have any questions, we can talk about it in class.